In this video, we're going to look at numerous strategies for finding areas. So here's a strategy we've looked at before, so let's review it. Find the area of the given shape by counting the square units that cover the interior of the shape. Assume the side of each small square is 1 centimeters. So for the most part, our figures aren't given on these nice grids where we can count the squares, but this shows us what we're doing when we're finding area. We're imagining that there are all of these small squares and we're counting the total number. So I am just listing the numbers as we go. Okay, and you probably know lots of other strategies already that are quicker than this, and we're going to investigate some of those soon. So 22, 23, 24, 28, 29, 30. Now we were told each small square is 1 centimeter, so we know this is 30 square centimeters. Now Carrie, Shari, Gary, and Larry were given the task of finding the area of the shape, but their teacher didn't give them the grid with the squares to count. Each student knew how to find the area of a rectangle, but they each came up with a different strategy for finding the area of the shape. So we're going to look at all of their different strategies. So let's start with Carrie's strategy. Okay. She decided, I am going to cut this into 2 pieces, okay, and I am going to find the individual areas of these 2 rectangles. So I'm going to draw them separately. There's this rectangle right here. We'll call this 1, and we'll call this 2. So let's see, we know the dimensions of this one, so you need to look at the shape, and right up here we know that this is 3 centimeters, and we know that this is 6 centimeters. So the area of this shape, the area of a rectangle, is 3 centimeters times 6 centimeters, which is 18 square centimeters. Now what about this piece right here? Well, we know this is 4, but we don't know this piece right here. Okay, so this whole length is 6, this length is 3, so this length must be the difference between 6 and 3, which is 3. Okay, so if this whole piece is 6, this is 3, we need to be able to add 3, so it will be a total of 6. So this smaller rectangle is 3 centimeters times 4 centimeters, which is 12 centimeters squared. So now we can add these pieces together, so the total area, since these aren't overlapping, is the sum of the 2 pieces. So 12 centimeters squared plus 18 centimeters squared equals 30 centimeters squared, which is the result we got before. Okay, so we're going to call Carrie's strategy an adding strategy, because Carrie cut the diagram into rectangles and then summed up the 2 non-overlapping pieces. Let's look at the next one. Now let's see Shari's strategy. So Shari decided to imagine that she had a full rectangle. Okay, so let's look at these pieces. So this was 4. Since this is 6 and we made a rectangle, this must be 2, because 4 plus 2 will give us this total of 6. And this piece right here, which we found before, 3 plus this gives us 6, so this must be 3. Now, she's thinking, well, I'll find the area of this whole rectangle. So let's draw a picture. And this will be 6 by 6. So 6 centimeters times 6 centimeters is 36 square centimeters. Okay. But she says we over counted a little bit because this piece is not in the figure. So she wants to subtract off the area of this piece from this total. So now let's look at this piece. Well, this was 2 centimeters times 3 centimeters, which gives us 6 square centimeters. So then Sherry said, I'm going to subtract the 6 square centimeters from the 36 to get this resulting amount. And this corresponds to our previous result. And we're going to call this a subtracting strategy. Okay, so a subtracting strategy is when you find an area larger than the original area you're finding and you subtract off the difference of what's not really part of the original area. Let's look at the next one. Okay, now we're going to look at Gary's strategy. So Gary is going to use what we call a move and reattach strategy. Okay. So he notices this is 3 centimeters and this is 3 centimeters. So just like Gary, he decides to cut it. Okay. But instead of finding these two areas, he says, well, I'm going to line up these pieces. Since these widths are the same, he's going to put 1 here and stack 2 on top of it. Okay, so this piece, notice they have the same length, so this is 3 centimeters. The length of 1 is 4 centimeters. And the length of 2 that we cut and put on top is 6 centimeters. So he says, I've made a new rectangle. I want to find its area. Well, notice this. We'd add these together to find this total length. So this is our new rectangle made up of 1 and 2. This is 10 centimeters. This is 3 centimeters. So our area is 10 centimeters times 3 centimeters, which is 30 square centimeters. Okay. Now we're going to look at one last strategy, Larry's strategy. Well, Larry's going to use a double and half strategy. So Larry sees this picture kind of like Tetris pieces. He says, I'm going to take this, and basically he's making a copy of this, and then think of flipping it up and then flipping it over. So this side is corresponding to this side. We know they're the same length. They're both 3 centimeters. Okay. This side is corresponding to this side. Okay, so again, this is a copy of this figure, but flipped and flipped again to the left. So this is the same as this. Okay. And the top part corresponds to this lower part. Okay. So he used this idea. Notice that our resulting rectangle is, this is 6 plus 4, which is 10 centimeters. And this is 6 centimeters. So he finds this area, and he sees that it is 60 square centimeters. But he says, well, this is 2 copies, because we have 2 copies of the same figure. I just have 1 copy. I just want this area, so I'm going to find half. So this is double the area. And since he doubled it to find this amount, now he's going to half the area. So we'll multiply 1/2, which is the same as dividing by 2. And 60 divided by 2 is 30 square centimeters.